The coolant and lubrication systems of CNC machine tools are one of the key components ensuring the normal operation of the machine. They each have different functions, but in practical applications, they often work together to ensure the smooth progress of the machining process. Once there is a failure in the coolant or lubrication system, the CNC system will stop working and issue an alarm. Hello, everyone. Welcome to the mini-lecture on intelligent equipment fault diagnosis and maintenance. Today, we will learn about the design of coolant and lubrication system control for CNC machine tools. In this lesson, we will learn about the design of coolant and lubrication system control for CNC machine tools. The learning objectives of this lesson are: 1. To understand the control requirements of the coolant and lubrication systems. 2. To master the design methods of the coolant and lubrication system control for CNC machine tools. Let's start with the control of the coolant system. 1. High-voltage circuit requirements. The high-voltage control of the coolant involves a three-phase 380 volts voltage that, after passing through short circuit, overload, and undervoltage protections, is output to the contactor KM5 and then to the cooling motor M2. The logic of high-voltage control starts with the control circuit KA2 signal outputting AC 220 volts to drive the coil of the AC contactor KM5. When the KM5 coil is energized, its main contacts close, and AC 380 volts is transmitted through these main contacts to the cooling motor M2, causing M2 to rotate and pump out the coolant. When the control circuit KA2 signal does not output 220V, M2 stops. 2. Control circuit requirements. PLC signal. After pressing the coolant button or executing M07, M08 commands, the PLC outputs signal Y2.6, which then controls the relay KA2, and subsequently, KA2 controls the contactor KM5 to achieve this. The logic of low-voltage control involves pressing the coolant button, which activates the CNC machine tool input signal X. Signal X has been pre-wired. Through PLC program logic operations, Y2.6 has an output, and the Y2.6 output signal drives the coil of relay KA2. The normally open contact of KA2 closes, delivering AC 220 volts to the coil of the high-voltage KM5 AC contactor. Furthermore, when the CNC system executes M07, M08 commands, it decodes these commands, identifying a valid X input signal. Signal X has been properly associated. Through PLC program logic operations, Y2.6 has an output, and the Y2.6 output signal drives the coil of relay KA2. The normally open contact of KA2 closes, delivering AC 220 volts to the coil of the high-voltage KM5 AC contactor. Let's continue to learn about the control of the lubrication system. 1. High-voltage circuit requirements. The high voltage for the lubrication motor comes from a 200 volts voltage generated by the servo transformer, which, after passing through short circuit, overload, and undervoltage protections, is output to the lubrication motor M3. The logic of high-voltage control starts with the normally open contact of the control circuit signal KA8 closing, allowing 220 volts voltage to pass through the KA8 contact to M3. Since the power is not high, it does not require a contactor. 2. Control circuit requirements. The lubrication system uses automatic control. Once the PLC is activated, the lubrication system can operate according to requirements, setting lubrication time, etc., with the PLC's Y2.5 point output signal controlling the output of the lubrication system. The output of Y2.5 drives the relay KA8, whose contact controls the lubrication motor. When the fluid level is low, a low fluid level alarm must be transmitted to the PLC's X3.2 point. The logic of low-voltage control involves the PLC control system automatically issuing commands. The command logic has been preset when the CNC system starts. At this point, the PLC's Y2.5 is active, and its output signal drives the coil of relay KA8. After KA8's coil is energized, 220 volts passes through the coil contact to the lubrication motor M3, starting M3 and spraying lubricant. When the coolant fluid level is low, the PLC's X3.2 point becomes active, and the PLC program stops the output of Y2.5. The program has been written, stopping motor M3 and pausing the spray of lubricant. In this lesson, we have learned about the operation circuits of the coolant and lubrication systems for CNC machine tools. It is important to note that, in some modern CNC machine tools, the coolant and lubricant may be part of the same system, known as the coolant and lubrication system. This system combines the advantages of both, serving cooling and lubrication purposes. Such a system design is more compact, more convenient to use, and can also reduce maintenance costs. Please complete the following exercises. That concludes today's lesson. Thank you, everyone.